Okay, number 8. A study was conducted to compare the proportion of single women getting more than 8 hours of sleep to the proportion of married women getting more than 8 hours of sleep. So we have two populations we're trying to draw conclusions about. Single and married. Of 1,000 single women, so sample size 1,000, 520 reported they sleep more than 8 hours. So that's the X value, 520. Of 1,000 married women, sample size 1,000, 510 reported they sleep more than 8 hours on a regular basis. Our job is to create a 95% confidence interval, so the confidence level is 0.95 for the difference of proportions. So most of the feedback I've seen so far is that nobody has any trouble getting the point estimate here. That's the best guess for the difference, but it's really the margin of error that's causing some trouble. Point estimate. What's the point estimate? X divided by n makes point estimates, Tyler, for each of these populations. So we'd have like a p hat here. 520 divided by 1,000 is 0.52. And a p hat here for married. 510 divided by 1,000, which is 0.51. Good? And now we're trying to estimate the difference of those two proportions. P hat 1 minus p hat 2, the difference between these two, 0.52 minus 0.51. That's a mere difference of 0.01. That's the best guess we have for the difference between those two things. All right, margin of error. That's where we have to find the formula in the formula sheet. 1 or 2 samples? 2 samples, so not up here. And then are we estimating the means or the proportions? The proportions. So we have this formula. I'd say this formula looks the scariest of all the formulas we have, so we're going big today. But it's not any different than what we had for only one sample. Like one sample looks like this. All we do is just twice, one for each sample. So we created already P1 and P2 hat. We know the sample sizes. It's just a matter of getting all this stuff in there correctly. So I'm going to copy the formula over to the problem. Margin of error is the critical value of z times the square root of P1 hat times 1 minus P1 hat divided by sample size 1 plus P2 hat times 1 minus P2 hat divided by sample size 2. All that under the radical. Earlier today, someone said it's just plug and chug. I totally agree. We have P1, we have P2. We need the critical value of z, though. Where'd that come from? Critical value of z comes from the table, right? The confidence level is 0.95. The critical value of z is the z value that corresponds to that confidence level. We had 2 options. You can read the very bottom of this T table. 0.95 is our confidence level. That's this column. And decide that it's 1.96. Or in the lecture notes at the very beginning, we had that summary table, or if you have your Z table, it's summarized also, 1.96. All right, so 1 byte at a time in the giant formula. The critical value z, 1.96 times the square root. P1 hat, 0.52 times 1 minus 0.52 divided by sample size 1, 1,000. Plus P2 hat, 0.51 times 1 minus 0.51 divided by sample size 2, also 1,000. Enter the calculator. That's what they're made for, calculators. This is exactly what people need calculators for. This is the critical value of z, 1.96, times the square root. I'm going to put all this stuff in there. I don't want to have to do anything on my own. So 0.52, parenthesis, 1 minus 0.52, divided by 1,000. No extra parentheses are necessary other than the ones that are in the formula right here. Calculator knows to make multiplication only after it does the subtraction and then do the division. So you don't have to like micromanage it. We do need to add this other term. So this calculator says everything's already under the radical. The only extra parenthesis you might add if your calculator doesn't extend the radical over this stuff is to do this. Add a parenthesis at the beginning and the end. What you don't want to do if it does extend the radical is arrow over. That gets you out. So yeah, yesterday I was helping someone and they had this and they got the margin of error wrong because this 0.51 business is no longer under the radical. So make sure you're under there. Plus 0.51 times 1 minus 0.51 divided by 1,000. So the margin of error that I get is 0.0438050134. Weberg asks for 4 decimal places, but don't stop there to make your limits. Remember, just enter this guy to 4 decimal places, but keep them around to make the lower limit and the upper limit. Lower limit would be the point estimate, 0.01, minus the margin of error, 0.043805, yada, yada, yada. Negative 0.0338 to 4 decimal places. And the upper limit is the same thing but plus. Oh, 0.053838. To 4 decimal places.